Vector problems involving velocity and distance. Let's look at this question. A man in a kayak can paddle at 6 meters per second. If he travels downstream in a current of 2 meters per second for 10 minutes, how fast is he moving and how far did he travel? So to figure out how fast he's moving, we need to decide how his paddling is related to the current. If it says that he's paddling downstream, that means he's paddling with the current. So when we go to draw our vector diagram, we're going to add our two vectors together to find our resultant vector. So let's draw a picture. Let's say we have a river, and we've got the man paddling down the river at 6 meters per second. If he's traveling downstream, that means he's traveling with the current. So we're going to put our two vectors in the same direction. So our current is 2 meters per second. If we want to find our resultant vector, we're going to add the two. So our resultant is going to equal the 6 meters per second that he's paddling plus the 2 meters per second that the current is flowing. So from an observer standing on the shore of that river, it would look like that kayak is going 8 meters per second. Now the next thing we're going to want to do is we're going to calculate how far he traveled. But before we can do that, we have to look at the units, because the velocity that we calculated is in meters per second, but the time is in minutes, and those units don't match up. So we're going to need to convert 10 minutes to seconds before we can do our problem. We need to remember that for every 1 minute, we have 60 seconds. That means that 10 minutes is equal to 600 seconds. Now let's look at our velocity equation. We know that velocity equals distance divided by time. If we want to solve for distance, we're going to have to multiply both sides by time. That'll give us distance equals velocity times time. Now we'll plug in our numbers. So we've got 8 meters per second for our velocity. We'll multiply it by 600 seconds, and that's going to give us a distance of 4,800 meters. So if a man paddles his kayak at 6 meters per second downstream with a current of 2 meters per second for 10 minutes, it would appear like he's traveling 8 meters per second, and he would actually travel downstream 4,800 meters. Now let's look at a different scenario. This time it says a man in a kayak can paddle at 6 meters per second. That part's the same. But it says if he travels upstream in a current of 2 meters per second for 10 minutes, how fast is he moving and how far did he travel? And again, with every one of these kinds of problems, we're going to need to include a vector diagram. So we need to decide what it means to say that a kayak is paddling upstream. That means it's paddling against the current. So if we draw our vector diagram, okay, the first thing we'll do is we'll draw our little stream here. We've got a man kayaking on our river at 6 meters per second, but this time he's paddling against the current. So we're going to put our second vector like this. Remember, whenever we have two vectors that we're putting together, we always attach them by the head of the first to the tail of the second vector. So our current is 2 meters per second. Our resultant is the difference between the two. So our resultant is going to equal 6 meters per second minus 2 meters per second, which would give 4 meters per second. So the man has the ability to paddle at 6 meters per second, but he's working against the current. So somebody standing on the shore would see that the man is only moving at 4 meters per second down that stream. We've got 10 meters or 10 minutes, so we need to take that 10 minutes and go from minutes to seconds. And then we want to calculate our distance again. We know that distance equals our velocity times our time. Our velocity in this scenario is 4 meters per second for 600 seconds. So our total distance this time would only be 2,400 meters. So because in this problem, the man is paddling his kayak upstream or against the current, he's not going to be able to travel as far as when he was traveling downstream or with the current. Now let's look at a third scenario. It says a man in a kayak can paddle 6 meters per second, same as before. If he travels, shouldn't say downstream this time, let's change this. If he travels across the river in a current of 2 meters per second for 10 minutes, how fast is he moving and how far did he travel? All right, so let's think about this one. Here's our river. This time the man's going to travel across the river. So that means he's going to travel like this at 6 meters per second. The current is going downstream at 2 meters per second. We want to find out how fast was he traveling. So this time we're looking at a right triangle. So when we talk about our resultant, we're talking about the hypotenuse of a right triangle. So we're going to need to use our Pythagorean theorem. We've got a squared plus b squared equals c squared. We're going to plug in 6 meters per second for A, 2 meters per second for B, and we're going to plug in R for C. So we'll have 6 squared plus 2 squared equals R squared. 6 squared is 36. 2 squared is 4, and that'll all equal R squared. 36 plus 4 equals 40. That gives us R squared. If we take the square root of both sides, that'll give us R. So R is going to equal 6.3 meters per second. And this time it's at an angle going downstream. Now that we know the velocity, we can go through and calculate how far downstream he went. So we've got our 10 minutes. Again, we want to go from minutes to seconds. We know that distance equals velocity times time. Our velocity now is 6.3 meters per second. Our time is 600 seconds. So the distance it would travel now downstream would be 3,780 meters. So we've got three case scenarios here. Okay, we've got where we're going to be adding our vectors together, and that's when they're going in the same direction. We're going to be subtracting vectors, that's when they're going in opposite directions. And we're going to have to use our a squared plus b squared equals c squared equation when the vectors are at right angles to each other. If you need to go back and listen to this video again, you can do that. You can stop it at any time and rewind it if you need to look at a particular type of problem again.